Okay, let's go ahead and get started. So, last time we took our exam, and I will have the final grades for those exams tomorrow. But let's go ahead and go over it today. So, number one. Determine whether the statement describes a population or a sample. The amount of money each person in your chemistry class spends eating out each week. So what would that be, a population or a sample? Any ideas? Yeah, there we go. Thank you. This is indeed a population because we're talking about the entire class. If we were just talking about a portion of the class, that would be a sample. Okay, next, if the researchers administering care know which partakers have been placed in the experimental or control group, but the partaker does not have this information, the experiment is what, single blind or double blind? Is what? It's actually single blind. So a double blind study would be where everybody is clueless as to what group each person is in. In this case, though, the researchers know what group the participants are in, whether they be in the experimental or the control group. So that would be a single blind study. Again, a double blind is where the researchers are also clueless as to which group the participants are in. Number three, determine whether an observational or experimental study is appropriate to address the following statement. A car wash operator wants to find out if a need for additional staffing exists. So, do we think this would be observational or experimental? Yeah, that's what most people are telling me. And honestly, I could make a case for experimental as well. Okay, so observational, yeah, he could look at his numbers for productivity or whatever you want to call it for the past few months and determine whether he needs to hire more staff, or he could just hire somebody and see if productivity increases or decreases. Okay, so I'm actually going to make this one a free question because I think either one of those would be appropriate. Okay, any questions? All right. Next one, a college administrator wants to know if the SAT scores of incoming freshmen have an effect on the end of year freshman GPA. The SAT scores would be considered what? The response variable or the explanatory variable? Good, yeah, that'd be the explanatory variable. Remember that the explanatory variable is what is explaining the phenomena. It's the driving force behind what is changing. Okay, so here we're looking at SAT scores and seeing if they have an effect on freshman GPA. Well, that's the thing that would be affecting the outcome. The outcome is the response to the thing that is changing. Okay, so very good, explanatory variable. Any questions? All right, let's go to the next one. So this one says, a mid-sized mobile carrier keeps records of complaints received from its customers. Complaints for last month are listed in the following table. What percent of the complaints are due to the category extra data usage charges? Round your answer to 2 decimal places if necessary. Okay, looking at this frequency right here, and we want to know what percent this represents of our total data. So we've got that number, that's good, but we need another number. What else do we need? Exactly. Good. We need the total number of all of these complaints that have been recorded so that we can determine what this is in comparison to that. Okay, so we're going to need to add up all of these frequencies. So 118 plus 99 plus 87 plus 92 plus 106 plus 89 plus 43 and then plus 156. And that comes out to 790. Now here's an important question. Am I going to put 790 on top of 87 or below 87 in a fraction? Below. Good. The one mistake I did see on this one was people making this the other way around. So 790 out of 87. Remember that we're talking about a part out of a whole. So it needs to be 87 out of 790. Okay. So there's a variety of ways we can solve it from this point. We could do 87 divided by 790 to get a decimal, and then convert that decimal to a percent by multiplying by 100. Or we could set up a proportion. Okay. And so to solve the proportion, we would multiply 87 by 100 and then divide by 790. Either one will get you the exact same answer, and indeed are doing the exact same thing, just with a little bit of a different logic behind them. So I'm going to do 87 divided by 790 and then convert to a percent. So 87 divided by 790 and then times 100 to get a percent gives me 11.01 if I round that. So there's our percent. Any questions? No? Okay. Next, consider the following data. It gives us a set of data here and says determine the mean, median, and mode. So what's the first thing that we should do with our data here? Put it in order, yeah. So I'll go ahead and put it in order for us, starting with negative 14, then negative 13, then negative 8, negative 7, negative 5, and positive 5. Okay, so we want to find the mean. So we're going to need to add all these together, and we need to make sure that we're adding negative numbers. Excuse me. So negative 14 plus negative 13 plus negative 8 plus negative 7 plus negative 5 plus 5 gives us negative 42. And what are we going to divide that by? 6. So we have 6 data points, so we're going to divide this by 6. And we get a mean of negative 7. Good. All right, next one, determine the median. So to find the median, we need to find the middle number, the number that is exactly in the center. So we count in from each side, and we have 2 numbers in the center here, negative 8 and negative 7. So we need to find the number that is between negative 8 and negative 7. What would that be? Is what? Yeah, there you go. Knew what you meant though. Good, yeah. Directly between negative 8 and negative 7 is negative 7.5. Good. All right, last part. What is the mode? Yeah, do we even have a mode? No. For us to have a mode, we need a number that repeats. Well, none of these numbers repeat, so there's no mode. Very good. Any questions? None? Okay. Next. Says, calculate the GPA of a student with the following grades. C for a 16-hour course, B for a 5-hour course, D for a 12-hour course. And then it gives the values of those grades. And then it says to round our round our answer to 2 decimal places. Okay. So the first thing we need to do here is convert these letters into actual values that we can use and calculate with. So what does a C represent? Yeah, there we go. C is a 2. How about a B? Good. And a D? Good. All right. So now that we have these converted to actual values, we need to calculate a weighted mean. So multiply our weights times our values. So what is 2 times 16? 32. Good. 3 times 5? 15. Good. And 1 times 12? Good. Okay. And what are we going to do with these 3 numbers? We're going to add, subtract, multiply, divide. Okay, we're going to add these because we want to know the total value that we accumulated taking these courses. Now, this is going to be out of the value that we attempted, so just the hours by themselves. So 16 plus 5 plus 12. Okay, so now we just need to calculate this. Let's see, 32 plus 15 plus 12 is 59. And then 16 plus 5 plus 12 is 33. And now we just divide, so 59 divided by 33 is 1.79 if we round. Any questions? Makes sense? Okay. Next. For the graph shown, determine which letter represents the mean, the median, and the mode. Letters may be used more than once. Okay. So remember that what this graph represents is frequency. So as this curve increases, the frequency of the numbers are increasing as well. So like if this was 1 right here, well, it's not occurring a whole lot, maybe once. But if this is like 8 over here, then it's occurring a whole lot. Okay, so this is frequency. So first of all, where's the mode? A, B, or C? B, yes. B is where this number is occurring the most. It's the peak. It's the highest frequency. Okay, how about our median? Of course, the median is the middle number. What? C, yeah. This right here splits our data into 2 halves. So half of our data is right here on this side of C, and then the other half of our data is here on the other side of C. Okay? Now, if this data were perfectly distributed, perfectly even, then C would be in the middle. Okay? Now, because this is skewed, this means that C is over here towards where there are more data points. Okay? Finally, what is A? Not a whole lot of, yeah, it's the mean. Pretty easy, huh? Okay. Any questions? All right. Next, again, consider the following data. It gives us a set of data, and it wants us to find the sample standard deviation and the range. Okay, sample. We need to use sample formulas here. Okay, so particularly with standard deviation, our formula is S equals the square root of the sum of x minus what? What comes next? Keep in mind this is a sample. X bar, very good. This is a sample, so we have x bar here. Of course, that is our sample mean. Then squared, and it's over what? You're close, it's a sample though, so it's n minus 1, yeah. For samples, we have to subtract 1 from n because we don't have all the data points in that population. If we had all of the data points in the population, then it'd just be n because we know everything. But we don't know everything. We're kind of projecting what we know about the sample of this population, so we have to subtract 1. Okay. So x bar is the sample mean. It isn't calculated any differently from a population mean. We just have this different symbol so that we know which one we're talking about. Okay, and n is what? What does n represent? Well, yeah, it is 6, but where did you get that from? Yeah, it's the amount of numbers that we have, the number of data points we have. Okay, so let's find this mean. So we need to add all these numbers up and then divide by n, our 6. So -5 plus -15 plus 3 plus 3 plus -5 plus -5 gives us -24. Divide that by 6, that gives us -4. Okay, so there's our sample mean. Now we can take these numbers, put them into our formula, and see what we get. So the first part, x minus x bar, we need to take each of these x values and subtract x bar. Now if we think about that, like the first one would be -5 minus, for this sign right here, -4. Okay, so what's going to happen here? We have a double negative, so it's going to become what? Positive. Good. So really this is going to be like -5 plus 4. And that's going to be true for all of these numbers. So all of these numbers are going to get plus 4. So let's see. -5 plus 4, of course, is what? -1, good. -15, -11. +3 plus 4. 7. And then the rest of them repeat. Good. All right, so we've got our x minus x bar. Now we need to square. What just happened? Okay, stream's back, I guess. Okay, so now we need to square. So each of these values is going to get squared. What's negative 1 squared? 1. 11 squared. 121, good. 7 squared? 49. And again, they repeat, so I'll just fill this in for us. All right, good, good. So now we have our x minus x bar squared, and now we need to do what? Add them. Perfect. So 1 plus 121 plus 49 plus 49 plus 1 plus 1 is 222. So the top part is 222, and we need to divide that by n minus 1, so divide by 5. And we get 44.4. Now, we haven't taken our square root yet. We've just found the stuff inside here. What does that represent? It's not standard deviation. What is it? Anybody remember the name for it? Okay, so the value we get right before we take the square root is variance. Okay, so in this case our variance would be 44.4. Now to get our standard deviation, we just take the square root of that, and we get 6.7 if we round it. Any questions on that part? No? Okay, so now we need to find the range. And remember, range is the largest number minus the smallest number. So what's our largest number? Oh, I'm sorry, of the original. Largest number is 3. Minus the smallest number. What is our smallest number? Negative 15. So again, what happens there? It becomes positive. So this is really 3 plus 15, and what does that give us? 18. There's our range. Excellent. Any questions? None? Okay. Next. And, in fact, the last question. Suppose that a company wishes to predict sales volume based on the amount of advertising expenditures. The sales manager thinks that sales volume and advertising expenditures are modeled according to the following linear equation. Both sales volume and advertising expenditures are in thousands of dollars. That is important for us to remember. Okay, so the linear equation that it gives us is estimated sales volume equals 49.48 plus 0.51 times advertising expenditures. So what this says is basically if we spend a certain amount of money on advertising, we should get a certain amount of money in sales. Okay. If the company has a target sales volume of $225,000, how much should the sales manager allocate for advertising in the budget? Round your answer to the nearest dollar. Okay. So again, what we want to do is we want to find out how much we need to spend on advertising if we want to make $225,000. So this is going to go where in our equation? Estimated sales volume. And what are we going to plug in for estimated sales volume? Because it's not 225,000, it's what? 225. Because we have to remember that both of these are in thousands of dollars. So this is 225 equals 49.48 plus 0.51 times advertising expenditures, which I'm just going to call A. Okay. So, we need to solve for A. In other words, get it by itself. So what's the first thing that we can do in working towards that goal? Perfect. Subtract 49.48 from both sides, of course, because we need to preserve balance here. So that cancels there. Let's see what we get when we subtract it from 225. Minus 49.48 is 175.52. Okay. Drop our other values down. Okay. Now what? Divide. Good. So we divide by 0.51 on both sides. So 175.52 divided by 0.51 gives us 344.15, and if we rounded 7. Is that my answer? Or is there something else I need to do? There's something else I need to do here. Remember that I converted this into thousands of dollars. So converted it from 225,000 to 225. So I need to do the same thing to this. I need to convert it back into a normal number because this is in thousands of dollars. Okay? So I will multiply this by 1,000, or in other words, move that decimal 3 places to the right, and that is now my final answer, 344,157. Any questions? No? Okay. How do we feel we did on this exam then? Pretty good? Good. All right. Yeah, and from what I've seen of the exams, they look pretty decent. There's a few places here and there that we had some common mistakes, but for the most part, it seems like we knew what we were doing. Okay. So, I am going to let Ms. Lamar get the lecture in this week before I lecture, and I'll pick up where she leaves off on Wednesday. Okay? So I think that'll do it for today, and I hope you have a good day.